Okay, so loop engineering is the term everyone in the AI coding space has been throwing around since early June, and I wanted to actually break down where it came from and whether it's real or just another label slapped on stuff we were already doing. Short version, it started with a blog post from Addy Osmani, a well-known engineer who used to work on Chrome and dev tools at Google, and he built on comments from two other people in the space. Peter Steinberger, who builds developer tools, had already been saying the era of typing prompts into a coding agent one at a time is basically ending, and that the real skill now is designing a system that prompts the agent for you. Boris Cherny, who leads Claude Code at Anthropic, said something similar around the same time, that his actual job these days is writing loops that prompt Claude, not prompting Claude directly himself. Osmani took those two comments, expanded on them, and published a long piece on June 7th that basically named the whole pattern. Before I get into what a loop actually is, it helps to walk through how we got here, because loop engineering is stacked on top of three earlier ideas, and none of them went away. Prompt engineering is the oldest one, and it's exactly what it sounds like. You write a good instruction, you give the model enough detail, and you get a better answer back. For example, if I ask an agent to write a reply to one customer email, that's pure prompt engineering. The model already has everything it needs in its own head to do the job. Context engineering showed up next, and it's what happens when the agent starts pulling in outside information on its own, instead of you pasting it in. Say I ask an agent to check the current shipping status of an order. Now it has to go query a database or call an API before it can answer me, and it decides on its own what to fetch and when. That's the agent managing its own context window in real time, grabbing what it needs, tossing what it doesn't. Harness engineering came after that, and this is where things get more structural. Context engineering falls apart once a task runs long, because the agent's context window fills up, and summarizing on the fly tends to lose important details along the way. So say I ask an agent to build me an entire internal tool from scratch, with a database, a login system, and a dashboard. That's way too much for one continuous context window to hold cleanly, so you need something outside the model, managing the whole operation, breaking it into stages, tracking what's done and what isn't. That external management layer is the harness, and tools like Claude Code and Codex are built around this idea already. Now here's the part that's actually new. Every layer I just described still needs a human to kick it off. I have to type the request, whether it's one email or an entire app build, and once the agent finishes, it just sits there waiting for my next message. Loop engineering removes that waiting part. Instead of you prompting the agent, you build a small system that prompts the agent for you, on a schedule, based on rules you set once and then walk away from. Osmani breaks this down into 5 working parts, plus one memory layer that ties them together, and honestly this is the useful part of his post. The first is automations, which are basically scheduled triggers. You tell the tool which project to run, what prompt to fire, and how often, whether that's every hour or every time new code gets pushed. Codex has a dedicated automations tab for this, and Claude Code handles the same idea through scheduled commands and hooks that fire at certain points in the agent's run. The second piece is worktrees, and this solves a very specific problem, which is what happens when you run more than one agent against the same codebase at the same time. 2 agents editing the same file at once causes the exact same mess as 2 people editing the same document without talking to each other. A worktree gives each agent its own separate working copy that shares the same project history, so their edits literally can't collide, and both Codex and Claude Code now support this natively. Skills are the third piece, and these are basically saved instruction sets the agent can call up by name, instead of you retyping a giant block of context every single time the loop runs. Connectors are fourth, and they're what let the loop reach outside the coding environment entirely into your ticketing system, your analytics dashboard, whatever data source the task actually needs. Sub-agents are fifth, smaller helper agents the main loop spins up to verify work, test changes, or handle one narrow piece of a bigger job, so the main loop isn't doing everything itself. And underneath all 5 sits external state, some kind of persistent memory or log file that survives between runs, so the loop remembers what it already did yesterday instead of starting from zero every single time. Put those together and you get something like this. Say you run a small website that tracks live sports scores. Games happen every day, scores change constantly, and bugs get reported by users at random times. Instead of you manually asking an agent to update scores or fix a bug every time something comes up, you set an automation to check for score updates every hour, another one to scan for new bug reports, hand each fix off through its own work tree so nothing collides, pull in a skill for how your codebase is structured, and let a sub-agent verify the fix actually works before anything ships. Nobody typed a single prompt that day. The system prompted itself. There's also a rougher, more manual version of this idea that's been floating around since earlier in 2026, called the Ralph technique, named after Ralph Wiggum from The Simpsons by a developer named Jeffrey Huntley. It's basically the same coding agent running inside a plain loop, hammering the same prompt against a task over and over until it's done. It's a cruder version of what Osmani is describing, but it's the same underlying instinct: stop typing every step yourself and let a loop grind through it. Now, is any of this actually solid, or is it hype dressed up as a new discipline? Osmani himself said in the same post that he's genuinely skeptical of parts of this, and he flagged real risks worth taking seriously, not just marketing spin. Token costs can spiral fast because an unattended loop that's checking things every hour, all day, adds up quickly, especially if the checks aren't tight. He also named 3 specific traps: verification debt, which is the loop claiming something is done without actually proving it; comprehension debt, which is code shipping faster than you or your team can actually understand it; and cognitive surrender, which is just accepting whatever the loop hands you without applying any judgment at all. And that criticism matters because plenty of people online pushed back hard on the term itself, calling it a rebrand of things developers were already doing with cron jobs and CI pipelines for years. That's a fair point, honestly. None of the individual pieces, scheduled triggers, isolated branches, helper agents are brand new inventions. What's actually new is that all 5 of them now ship built into the same products. Claude Code and Codex both support the full set natively, so you're not duct taping bash scripts together anymore to get a working loop. You're just flipping settings inside a tool you already have open. Whether loop engineering becomes an actual discipline people study or just fades into, yeah, that's just automation, probably depends on whether the verification part holds up in practice. A loop that runs all night and produces confident, polished, completely wrong output is worse than no loop at all, because nobody's watching it happen. So if you're going to try building one of these for your own project, the advice that keeps showing up from people actually running them in production is to start with one tight loop, one clear check for done versus not done, before you ever let 5 agents loose on the same codebase overnight.